Good morning, everyone. This is Anamika Bharali, and I'm here with our team, Shruti Mundargi and Saniya Kapur. We are here to present our project Locate Smart AI, where we've used a Snowflake marketplace database, and we've also used LangChain as an LLM to interact with this database through natural language. So we'll start with this project, and let's have Sanya start explaining the database.
Hello, everyone. This is our project. It's called the Locate Smart AI app. We live in a world where doing research about what area, what state, what place to live in is super important. And so, what our app does is when you give it a city or a pin code, it tells you about what the crime rates in that area are, what is the rent or mortgage price, and what is the livability in that place according to how many schools there are, how many hospitals there are, and things like that. So I'm going to first take you through the data set that we've taken from Snowflake Marketplace. We've taken our four data sets from CyberSync. The first one is financial and economic analysis. It has all the details about inflation, unemployment rate, housing starts, interest rates, etc. that are important to understand, whether in that city, these stats really matter. Then we have U.S. housing and real estate essentials. In this, we have the mortgage prices, migration rate, addresses, things like that. The crime statistics tell you about how many crimes happen in a particular city or in a particular zip code, and what kind of crimes take place. Point of interest addresses tells you about, maps all of these above data sets to the specific addresses. So you can search by address as well. So I'm going to take you through what our model looks like. So first, we have created our own database using the datasets from CyberSync. And these are the views that we have produced to make sure we only take those tables that are extremely valuable to our final product. With those, we have made three SQL processes. And with that, and from those, we have called our user-defined functions. So what these does is these SQL processes, one tells you the statistics of what the prices of rent and what mortgage prices are there in that particular area. The crime unemployment ratio gives you the crime rate in that area, the unemployment rate in that area, and gives you an analysis on on what basis these two factors are related in that particular area. And third view talks about employment POI analysis. In this, we see what kind of schools, and infrastructure there is in that particular area, schools, hospitals, etc. So with these three SQL processes, we create our UDFs. One tells you a comparison between whether you should buy a place there, the mortgage rate, or whether you should rent a place there. And the crime to unemployment ratio gives you a ratio of that area. Like it says, crime to unemployment, it gives you the ratio of crime to unemployment. And life quality index calculates all of these factors in mind and what kind of infrastructure there is in that particular area, and gives you a number with which you can understand what life quality is in that particular place to make the most viable decision. With that, all of this process is then called in LangChain, where you can ask certain questions. You can query it in natural language, and you put that in LangChain and on Streamlit, and it processes the whole database. So that is how we have proceeded with our model. Now I would request Shruti to take over.
Okay, so let me take you through our Snowflake database, and let me share my screen. So this is our Snowflake database. We have the 6 views which we have created from the 4 data set as Saniya mentioned. These 6 views are further used to create our SQL processes and our functions. So for example, let's see the Okay, so let me take you through the database of our Snowflake and what we have created. So these are the 6 views that Sanya was talking about. The first view is BLS employment view, which has data, the like GeoID variable name, which has like features such as the unemployment rate, if it's seasonally adjusted or not, if it's annual or monthly, and like that. And then there is a particular value, which is the employment rate for that particular GeoID. And the next view here is CPI rent view, which is basically a consumer price index. And here you can see the particular GeoID and the year for which the consumer price index was calculated. And here is the final CPI. The next view is a geo view. So basically we have created this view because all our tables were mapped only with geo ID and not the name. And there was another table which had all the had the names for that particular respective geo IDs. And here we are connecting them. So the next one is a home mortgage view. Here you can see that we have the year, the geo ID, the particular loan amount. So this basically shows us like all the loans that have been taken in any kind of area, its interest rate, the property value against which the loan has been taken, and it has all the insights about any kind of property that was bought through loan. And next is crime statistics. Here you can see that there is like geo ID and then the geo name. Then there is variables such as the daily count of all the incidents that are happening, or what kind of incidents are the offense category, and the count. So here you can see the daily count. Basically, the value denotes the daily count of any of the incidents that happen. So if basically here in the first row, you can see that for this particular GeoID, the daily count of any incidents happening is 6. So 6 incidents happened for that particular GeoID. And then we have US point of interest view. Here we're just taking information about all the kind of hospitals, schools, any restaurants, cafes, etc. that are there in any particular place. For example, now here for this GeoID, you can see like what is the company name, the PO, the company category. So here you can see the counseling and mental health name and everything. So here you can see a Stonecraft Studios, which is a contractor category, and like that. Okay, so next would be our SQL processes and functions. So okay, and let's go to here. For example, this SQL process. What this SQL process does is it. Let me show you the code here. So what this SQL process does is using our US POI and US POI view and BLS employment view, it creates like the total number of unemployment rate or total number of schools, health, education in a particular area. So if you see the data here, you can see that the name, so the geo ID, the geo name, the state name, and the unemployment rate, total number of schools, total healthcare, total cafes, or any sort of restaurants that are available in that area. So this table gives you an information about what kind of what kind of quality you will be able to experience. So based on this view, there is this function created. This UDF takes 3 things as an input. One is GeoID, second is state, and then next is city. And using these 3 inputs, it will give you a life quality index. I've added a formula there in which gives you like an output. We'll run all the user-defined functions later. So next user-defined function would be explained by Anamika.
Hi everyone, this is Anamika. So I'll be going over the home purchase data view. So this one was used making the BLS employment view and the geo view. So the BLS employment view is the Bureau of Labor Statistics, and the geo view will give us all the cities and the addresses of each geo ID. So what here we have done is we've used the year. It is this statistic is recorded the average loan amount for that geocode, the average interest rate in that geocode, and the average property value if we were to buy the average property value. And this is all average according to the year it was recorded, and the geocode. We've also recorded the CPI rent of primary residence. So primary residence means if a person has more than one house or property, we are using only the first one because we are assuming that not most people will be able to buy more than one residence. So we are comparing rent, a property value. So if we were to buy, if what loan amount are we getting in the market, what is the average interest rate, and what is the property value, and in the same time, what rent will we be paying if we are renting the place instead. So we move on to buying versus renting UDF. So this is just to compare. Oh, was it my okay? So oh, shoots. So we will be moving to the buying versus renting UDF. So with that data, we can just choose. We can just give a we can just give one input of a geo ID, and it will tell us the comparison between the rent and the property value if we are buying. So this is the point of the UDF, buying versus renting. Uh, my teammate Sanya will move on to explain the next one.
So the SQL process that I'll be explaining right now is called crime employment ratio. And so you can see I have joined two tables. One is BLS employment view, and the other one is urban crime statistics view, to then find out what kind of a relationship there is between unemployment and crime in that particular area. So I've taken geo name, which is the zip ID, city, year, annual incidence, unemployment rate, and crime unemployment ratio. Um, and I'll be and with this crime unemployment ratio, I've used the following formula. Yes, as you can see in this crime unemployment, I just want to show you the formula that has been used to then find out the crime unemployment ratio. We've taken urban crimes from urban crime stats table. We've taken annual incidence, and from labor stats we've taken the value, and we've divided the two to get the unemployment ratio. So then in our UDF, yes, in our crime unemployment UDF, you can see how when you've asked to enter these three particular values, uh, uh, and then you are asked to give the following data. So I think the UDFs will be demoed by Shruti.
Okay, so let me quickly run each of these functions. First, let us begin with buying and renting. Let me add one geo ID. Okay, let me just verify.
40.
And here we have the output. Okay, now let us go to the finding crime and unemployment ratio. I will add three parameters that this requires. First is the zip ID. Next is the city. And next is the year of which we want to get the information. So you can see the crime and unemployment ratio for that is 484. Similarly, if we can run life quality index, and the 3 parameters that it requires for us to get, which is zip ID, state, and city name. And here you can see that we have our life quality index printed. So this is just like a Python local version of how our functions actually work in the Locate Smart AI. And here this is our like UI. UI का क्या करना है? अभी तक दिखाया था क्या UI? नहीं दिखाया था ना? नहीं. Okay. So this is our UI, and you can अरे run क्यों होने लग गया? Stop it. So this is just like a Python local version of how our functions actually work in the Locate Smart AI. And here this is our like UI. As you can see in the chat history that we had asked it the question of unemployment rate in Boston in 2022, and it has given us the answer for it. Let's add one more question. And so we are asking it to name 10 random geo names with the primary rent of the residence and property values.
Hi guys, so I'll be going over the line chain integration. Let's get, okay. So we just created a connection with the with the Snowflake database, and like so we have created an instance con. Now using this con, we'll be creating different data frames using Panda. So like we've given all the queries. We've just done select star so that we get the whole of the views that we have created in Snowpark, and we'll just create data frames using Panda. So for the input variables, we give the query and the con variable. The con variable again is the one we use to connect Snowflake. And we have used a local database SQLite 3. This is so that we can use all of these data frames, create and use these separate tables and create one unified database. So the unified database we've chosen to name as Harmonize. Okay, so here we have closed the connection. It's very important to close the connection after we have created the database, because it can lead to in data being lost. Okay, so we've also created an instance LLM with key. So this will just be an instance giving the OpenAI pass key that we have for our own account. Okay, so temperature has to be 0. What is temperature? So temperature is just like a p-value for a t-test. So the smaller the better. Is the same way. Temperature is between 0 to 1. The smaller the better, the smarter the answers we get. Okay. So we have used the LLM key. We have used SQL database toolkit, and we are executing the create SQL agent. Mm, so when we go on, this. Uh, okay, yeah. So so after with this instance, you've just created used agent executor. What is an agent executor? This agent executor just executes all the Python, Python functions that we have created that you've already seen in Snowpark, and that is it. The rest of it is all the Streamlit the Streamlit code for the for the Streamlit UI to work. But as far as the connection and the execution is concerned, this is where the execution happens, and this is where we're connecting the database. So that is it. Now let's go back to the UI that we left running. As you can see, we have finally gotten the comparison between the rent of the primary residence and the property value for 10 random geo names. So the output also has the geo name, so the city name, and also has the rent of a property if you want to rent it, and the purchase value and interest rates if you want to buy it. So this is it, and this is our project. I hope you liked it. Thank you.